It doesn't need. Make sure you have a piece of paper in front of you. It can be a scrap piece of paper. It doesn't need to be perfect. Divide your paper in half. On one side, write healthy digestive system, and on the other side, write McKenna's digestive system. Next, create an outline of the upper part of the body. It does not need to be perfect. Notice I'm leaving an opening for the mouth. Try to leave space in the middle of the body because we know we're going to have a lot to represent here. Next, I drew my graham cracker and I made it 5 different colors. The red represents the glucose and the complex carbohydrates because we saw they were made of the same atoms. The green represents protein. I don't have any amino acids in the mouth, so there's none there. The orange is fat. The blue is water. And the brown is fiber. Take a moment to draw your graham cracker with the food molecules. Next, I know that in the mouth, the food starts to get broken up by chewing. So I'm going to draw it like this. 1, 2, 3, 4, 5. But I also know that in the mouth, a chemical reaction is occurring because the complex carbohydrates are breaking down into glucose molecules. I'm going to draw 1, 2, 3 to show that the complex carbohydrates are being broken down into glucose molecules. I'm going to label this glucose. And I'm going to draw an arrow and say chemical reaction because the atoms are being separated. And all this is happening in the mouth. The next organ in the digestive system is the esophagus. So I'm going to draw my esophagus going down to about here. And I'll label it ESOPHAGUS, esophagus. And I'm going to draw an arrow, but we know that no digestion happened in the esophagus. The amount of food molecules stayed the same. So I'm not going to draw anything happening there. Next comes the stomach, which we saw in our diagrams is higher than what you might normally think of as your stomach. So I'm going to draw my stomach. It's kind of like a moon shape. I'm going to label it. And I know that in the stomach, more chemical reactions are happening. Like complex carbohydrates breaking down into glucose molecules. I have my protein breaking into amino acids. I have my fat breaking into fatty acids. And I have my fiber, which is not breaking down. There's no chemical reactions. And again, I'm going to draw an arrow here and say chemical reactions. And I already labeled these little red ones as glucose. If I can fit it, I'm going to draw a little arrow. Amino acids. That's green. The proteins are breaking down into amino acids. And this one is fatty acids. Next, I've got the small intestine. Now remember that the small intestine is all wrapped up like this. And then around it, we've got the large intestine. I'm drawing the smaller food molecules that are broken up, and I know that they're being absorbed into the bloodstream, and I'm going to label that. Absorbed into bloodstream. I'm going to make sure I label that. Small intestine. And then I know that the food goes through the large intestine like this. I know that some of the water, not all of it, but some of the water gets absorbed at that point. And I also know that in the large intestine, I've still got my fiber that hasn't been broken up at all. And some of the smaller food molecules are still being absorbed. And then out comes the poop. I know that poop is made of mostly fiber that did not get broken down in the digestive system, and then water. So let's look at our model one more time. What does this represent? This represents the graham cracker and all of the different food molecules. What does the color green in my model represent? In my model, the green represents the protein. Now we've got the mouth. What do we see happening in the mouth? A chemical reaction breaking complex carbohydrates into glucose. Now we see the esophagus. What happens in the esophagus? Nothing. The food is not digested and there's no chemical reactions. Next we have the stomach. What happens in the stomach? A lot of chemical reactions. Complex carbohydrates are breaking down into glucose. Proteins are breaking down into amino acids. Fat is breaking down into fatty acids, but nothing is happening to the fiber. Next, it goes into the small intestine. Some of those chemical reactions are still happening to break down the larger food molecules. And what's happening to the smaller food molecules? Yes, the smaller food molecules are being absorbed into the bloodstream. Finally, the food goes through the large intestine. The remaining food molecules get absorbed, and it comes out the bottom. In a healthy digestive system, which of these food molecules are found in poop? Only fiber and water.